Alright, hello boys and girls. Today we're going to be doing multi-step equations using fractions and decimals. This is almost the same thing that you've already done, except now we're using fractions and decimals instead of integers. You've done multi-step equations before. We're going to be solving using those same rules that we used before. Make sure you have this written down. Make sure you take really good notes today. Write down any questions you have. We're going to take a look at the first problem. We have 1/4 x plus 3 equals 2. Again, this is very similar to the multi-step equation unit with integers. The only difference is that we have those fractions and decimals, so we're still following the same rules. Our whole goal is still to isolate that variable. We want to get x by itself. In order to do that, we need to do inverse operations. If you want, you can, just like in the two-step equation quiz, you can make your house around that 1/4 x. Keep in mind that x is your prized possession. It's whatever's really important to you. You need to get inside that house to be able to get to that x. That 1/4 is protecting your x, but then this plus 3 on the outside is not letting you get inside the house. This is the bad guy. We need to get rid of this. In order to get rid of a plus 3, we need to do the inverse operation of addition, which is subtraction. So we're going to subtract 3 from both sides. On this side, it cancels. Bring down that 1/4 x. Again, if you have a smaller number minus a bigger number, this is where we're going to do keep, change, flip. And we have unlike signs. Unlike signs, subtract this time. We're going to do 3 minus 2. Keep the sign of the larger number. 3 is bigger, so we're going to keep the negative. So we get -1. Now, we know that in between that 1/4 and the x is an invisible multiplication sign. And we know that the inverse operation of multiplication is division. So we could go ahead and divide both sides by 1/4. But you can see this looks like quite a bit of a mess here, okay? You can do it this way, like I said, show that it cancels out. You can make this over 1. And then you can look here and see, well, it's division. We know from last week that we have to do keep, change, flip, your KCF. So we could do -1 over 1. Change your division to multiplication. Flip that fraction and make it 4 over 1. But now you can see, if I had 1/4 times x, the inverse operation, I did all of this work to divide by 1/4. And I ended up just multiplying by the reciprocal. So if I take this 1/4 over here, and I just multiply by the reciprocal, that's the exact same thing as dividing by 1/4. So in order to save yourself a little bit of time, and so it doesn't look quite so messy, let's erase all of this mess, and let's just go straight into multiplying by the reciprocal. We're going to skip a couple steps. If I multiply this side by 4 over 1, I have to multiply this side by 4 over 1. We're going to make this over 1. Just show me that it cancels out. We know with cross-canceling, 4 goes into 4 ones, 4 goes into 4 ones. 1 times 1 is just 1, and 1 times x is just x. So all of this cancels out. Just show me that and bring down that variable. Over here you have a negative times a positive. We're going to get a negative answer. 1 times 4 is 4. 1 times 1 is 1. 4 divided by 1 is 4. So we end up with -4. Keep in mind on all of these problems, it's going to be really helpful, especially on a test or a quiz, to take that number and plug it back into your original problem. Plug that in for the x and see if you get 2. If you do, that means you did it correctly. If not, we know we did something incorrectly, so we need to go back and fix it. Okay, go ahead and write this one down. -1/5 y plus 2 equals a -3. We're going to solve this one the same way. We're going to draw that house around that -1/5 y. The inverse operation of addition is subtraction, so we're going to subtract 2 from both sides. On this side, show me that it cancels out. Bring that -1/5 y down. Okay, we have negatives with subtraction, so whenever that happens, we know we have to do leave, change, opposite. And then we end up with same signs. Same signs, add and keep the sign. So -3 plus -2 gives us -5. Now, again, just like on the last problem, if you want, you can divide by a -1/5 on both sides, but we know that dividing by 1/5 is the exact same thing as multiplying by the reciprocal. So I'm going to multiply by a -5 over 1. Negative times a negative gives me a positive, and then again, it's just going to cancel out. Show me that. If I do it on this side, I also have to do it on this side. Make it over 1. A negative times a negative gives us a positive, and 5 times 5 is 25. 1 times 1 is just 1. And then 25 divided by 1 is just 25. Okay? Alright, write down this one. On this one, we need to use the distributive property. So we're going to distribute before we can do anything else. Again, when you do the distributive property, it helps to draw those arrows to both things in the parentheses. The first thing, 1/2 of n, that's just 1/2 n. 1/2 of -8 is -4. And kind of ignore that line. That's not supposed to be there. It's really just 6. Okay? Again, if it helps you to draw your house, by all means, draw your house. The inverse operation of subtraction is addition, so we're going to add 4 to both sides. On this side, it cancels. Bring that 1/2 n down. 6 plus 4 is 10. And now we're ready to multiply by the reciprocal. So we're going to multiply both sides by 2 over 1. You can see when you multiply by 2 over 1, 2 divided by 1 is just 2. This still cancels, but you're really just multiplying both sides by 2. Okay, so we're going to bring that variable down. 10 times 2 is 20. Again, it can be really helpful on tests and quizzes if you take that number, plug it back in for your n, do 20 minus 8, and then we're just going to figure out, first of all, 20 minus 8 is 12. Half of 12 is 6. So we know we did it correctly. When you turn in your test, you should almost know immediately what score you got, because if you plugged them all back in and you know you did them correctly, then you should know you got 100%. Okay? We don't have time to go through all of these ones with fractions, but just keep in mind 3/4 of 8. If you had to take 3/4 of 8, you can break that 8 into 4s, 2, 4, 6, 8. Take 3 of those groups and you end up with 6. Or you could have just worked it out and did 3/4 times your 8 over 1. And then you can see when you cross cancel, you still get 6. So sometimes you will be distributing that fraction, and we're going to do a lot more practice with that during class. I just don't have time to go through all of them today. So we're going to look at decimals now. Everyone write this problem down. We have 7/10 c minus 10 equals 5/10. On this problem, just like the last ones, the only thing that's different is that now I have decimals instead of fractions. You can still go ahead and make your house. Okay, the bad guy in this problem is that minus 10. In order to get rid of that minus, we're going to do the inverse operation of subtraction, which is addition. So we're adding 10 to both sides. It's so important when you add and subtract decimals that you have to line up your decimal points. Right now on this 10, we know that decimal's at the end of the number. So I'm just going to start by putting my decimal here and writing my 10 in front. You can fill in that placeholder with a 0 there. Just make sure you show me it cancels out on this side. I'm going to bring down that 7/10 c, and I'm ready to add. 5 plus 0 is 5. Bring that decimal point straight down. 0 plus 0 is 0, and then we still have that 1 to bring down. So we get our 10.5. 10 and 5/10. Okay? Next step, what's invisible but in between my 7/10 and my c is a multiplication sign. The inverse operation of multiplication is division, so I'm dividing by 7/10. On this side, it cancels. On this side, top number, keep in mind, always goes inside the house. So we're going to take that 10 and 5/10, we're going to put it on the inside, and we're going to take 7/10 and put that on the outside. Okay, I can't divide with a decimal on the outside. I need to turn that 7/10 into a whole number. In order to do that, I need to move my decimal point. We need to move it to the right. So I'm going to move it one place. Now it's 7. It's a whole number. Since I moved it over one place here, I need to move it over one place here. So this becomes 105 divided by 7. 7 fits into 10 one time. 7 goes below. 10 minus 7 is 3. Bring down that 5. 7 fits into 35 5 times evenly. So we're going to show that we're done here because we get 0. And our final answer, all we have left here is C equals our positive 15. Okay, again, same with decimals. Plug that 15 back in there and see if we get our 5/10. Okay, go ahead and write this problem down. Again, you can go ahead and draw that house. We want to get rid of that bad guy, a minus 3 1/10. In order to get rid of that, you need to do the inverse operation. Again, the inverse operation of subtraction is addition, so we're adding 3 1/10 to both sides. On this side, you're showing me that it cancels out. We're bringing down that negative 8/10 k. And right here, we need to see it's a negative plus a positive. Think about your song, unlike sign, subtract this time. So we're going to take our bigger number minus our smaller number. It's already in the right order. I'm ready to subtract. 3 minus 1 is 2. 8 minus 3 is 5. And then keep the sign of the larger number. Ignore your signs. 8.3 is bigger. So we're going to keep that sign. We get our negative 5 2/10. Okay? In between your k and your negative 8/10 is a multiplication sign. The inverse operation of multiplication is division. So we are dividing by a negative 8/10 on both sides. Okay? On this side, show me that it cancels. Bring that k down. You can see right here, negative divided by a negative, you know is going to give you a positive. So you can now just go ahead and ignore those two negatives. Pretend like they're not even there. You've got 5 2/10. We're dividing it by 8/10. Again, I cannot divide with a decimal on the outside. You need to move it over 1. If I move it over 1 there, I have to move it over 1 here. Okay? This is really just 52 divided by 8. 8 fits into 52 6 times. 48 goes below. Subtract, we get 4. I'm out of numbers to bring down, and I don't have any zeros. You can't actually add any zeros until you add that decimal point in the problem, and keep in mind it shoots straight up in the problem. Now you can add as many zeros as you want. I'm going to bring that 0 down. 8 fits into 40 5 times. So I'm going to put that 5 here, 40 below, and we know that our answer is 6 5 times. Okay? The next problem we're going to do is 9/10 x plus 2 3/10 x equals a negative 6 4/10. At this point, I'd like you to go ahead and write down the word green apple. This is this week's key word. The reason that this problem is different than the other ones is because we have an x here and an x here, which means before I can do anything else, I need to combine like terms. These are like terms, so we can go ahead and circle those, and now I'm ready to combine them. Keep in mind when you have decimals, it's so important when we're adding to line those decimal points up. 9 plus 3 is 12. 1 plus 2 plus 0 is 3. Bring that x down. So we end up with 3 2/10 x equals your negative 6 4/10. Now this is just a one-step equation. This is very easy. The last step, inverse operation of multiplication, is division. So we're going to go ahead and divide both sides by your 3 2/10. On this one, it cancels. Bring that x down, and we're ready to divide. So I have negative 6.4 divided by my 3 2/10. Can't divide with that decimal on the outside, so we're going to move it over one place here, move it over one place here. This becomes negative 64 divided by 32. A negative divided by a positive gives me a negative. 32 fits into 64 2 times evenly. Okay, so we're ready to go ahead. Put that here. Again, you can always go back and check your answers. It's just now we have to plug negative 2 into 2 different places. Again, we're going to be practicing these a whole bunch in class tomorrow. Please write down any questions you have. If you need to go back and look at any of them, please do so, and I'll see you tomorrow.